Good morning, good afternoon, good evening, everyone, and welcome to our webinar. Thank you for spending some time with Polera Technologies, Software AG Connex, and MeshIQ. Today, your hosts will be discussing how to turn mainframe data into real-time intelligence for AI. The purpose of today's webinar is to give you perspective and thought leadership on the role that mainframe data has for AI initiatives, and more importantly, an option to access mainframe data and move it in real time for those AI initiatives. I am Adam Podracki, Chief Revenue Officer, and I will be joined by Josh Minthorn, Director Application Modernization at Polera Technologies, and Dimos Economikos, Principal Systems Engineer at Software AG Connex. Josh will give you his perspective on AI and the role of mainframe data. I will introduce you to a solution set provided by Software AG Connex and MeshIQ to connect to and move mainframe data in real time. And Demos will provide a demonstration of the solution set. We will follow this with a wrap-up and short Q&A session. Before we start, I have some quick housekeeping items to mention about today's session. This session will last approximately 30 minutes with a QA session at the end. It will be recorded, and we will share a link to the recording in the next few days. If you have questions, add them in the Q&A section in the top right section of your GoToWebinar screen. Again, thank you for joining, and let me introduce our first speaker, Josh Minthorn, Director Application Modernization at Polera Technologies. Josh?
I appreciate it, Adam. What I want to talk about today is a problem that nearly every enterprise with a mainframe is running into right now. And that is that the AI initiatives are only as good as the data behind them. And a huge share of the most valuable data, that most trustworthy data, lives on the mainframe. More specifically, on the mainframe in legacy data stores such as VSAM, IMS, and AWS. So I want to dive a little bit more into some use cases around AI and in the mainframe. So here's the thing is that we are seeing when we're working with our customers. So let's think about the first one there, that agentic AI. So these are agents that don't just answer questions like a chatbot. What they're doing is they're taking information and then taking action. For instance, a customer service agent that could look up a policy, maybe check a claim status or update an account balance. Those things have to reach into the core systems to be able to go ahead and do that. Again, these are the core systems that are in use today. Now, another use case around AI, but it's a little bit different, is when there's retrieval augmented generation, or RAG. Now, with this, what you're doing is you're grounding large language models in your actual data. And the reason you do that is that you don't want them to do what we call hallucination. In other words, we want them to be accurate. So if we ground it in your data, you have accurate and defensible answers. And you can't ground a model in a summary or a nightly extract. You really need that transactional record. And the third use case that we commonly see is the real-time analytics and decisioning. This goes into things, for instance, fraud detection, underwriting, what's the next best action, all of which lose value the moment that data is stale. So for instance, a fraud model that's working off yesterday's transaction isn't really a fraud model, it's more of a history lesson. So the common thread with all of these is how current and complete and trustworthy is the underlying data. And for most large enterprises and the customers we work with, it's the system of record, which is on the mainframe. So let's talk about the legacy data store. When we say this, we're not talking about, as a lot of people think, some dusty archive. What we're talking about is live transactional data that's core to the business. And again, this is data that's typically stored in things like maybe VSAM, IMS, and database. These things are typically more challenging to get to. However, what needs this data is workloads that are mission critical, that have been built over decades, and they're processing the majority of transaction volumes today. Now, this isn't a system that anybody is going to just rip out, right? It's too fast, it's reliable, it's just deeply embedded into daily operations. So then you again, what do you face the challenge of? Is that this data was designed for the applications of its era, That's batch jobs, terminal screens, and other things where they're tightly coupled, not really built for APIs, streaming pipelines, or AI frameworks. The data is excellent. This is not a question of the data quality. It's about the access patterns. So why is this critical? So we look at without direct access versus what happens when you have direct real-time access. Without direct access and you're using AI, your answers are going to be built on stale batch cycle data. We also will see that when you have shadow copies of mainframe data, then your data is now getting multiplied, which becomes a security concern. It also, again, is stale data. And the other part is that there's new reconciliation and security exposure with every copy that is now made. Not only that, you just don't know where it is and how up to date it is. When you compare that to direct real-time access, which you'll see here how this works later with Demos, is you're going to see how AI always works from what's true right now. That data gets updated. That data is now available to the AI. You no longer have to maintain duplicate data stores or secure them. So now you've removed the security and the maintenance and everything that comes with that. And not only that, now everything that wants to use this data, AI or not, can go one place for it. So now you have better security. And that's how you get to one connected path from your source system to your AI applications. So what will this look like? Oh, is we'll see here in a little bit. It's going to look like where you have on the left, you have AWS, IMS, or VSAM. And two things come together. One from software AG, known as Connex. The other piece is with Mesh IQ, which is where Adam comes in. And then you would have your AI applications. So what does this allow us to do? It connects to legacy databases and data stores and unlock that data to make it look like it can be accessed via our standard query language or SQL. And then what you do is leveraging Mesh based on using Apache Kafka, which is a data streaming platform, which has massive scale. So this is all about making it easy and unlocking that data at scale so that it can easily be accessed. So what are we ultimately looking for in terms of the challenges that we're solving? One, we want to get rid of these batch extracts, that we're not having shadow copies and everything else. Two is that because we're not copying those things, we remove the burden in terms of having to manage those things. The other one is we get no shadow copy sprawl, which is, again, we're not having those batch extracts and those copies and things like that. We can get directly to the data as opposed to duplicating it and storing it in multiple places. We get full operational visibility. We can see what's asking for data and at what volume and everything else. And again, it's all coming back to making sure this is performant and that AI data is accurate. The other piece is that there's zero disruption. You don't have to rip and replace anything of the current data stores. You're just unlocking it for more modern technology access, and especially around AI. And last but not least, who is Polera? So we focus on bringing together our client relationships and understanding challenges along with our partners and what they have in terms of solutions in bringing those things together. And it's really about driving outcome-based results to help customers save money, improve lives, right? Working lives and everything, maybe reducing their risks, and that can go into security and a lot of other things, but also increasing efficiency. And we do that through our AIM methodology, which means we can advise, we can implement, and we can also manage. So that being said, I appreciate your time. I'm going to turn it back over to Adam.
Thank you, Josh. I'm going to spend a few minutes introducing a solution set from Software AG Connex and Mesh IQ to address this challenge that Josh was just mentioning. So why legacy applications need real-time streaming? Whether it's fraud detection, faster underwriting decisions, or orders and returns, critical data resides on the mainframe, and accessing it in real time is paramount. But there are some challenges that you deal with every day. I don't have to tell you the impact of not having access to real-time data, but here's some examples. But it's really simple. Locked data slows you down. It limits your revenue and it increases your risk. So why traditional approaches fall short? Because accessing mainframe and legacy data and moving it in real time has its challenges. There are common themes across both data access and real-time movement, and it's these three things: cost, complexity, and multiple tools. It's expensive, there's many moving parts, and you have multiple tools that you need in order to solve this problem today. And the two capabilities that are required, Josh mentioned earlier. You have legacy data connectivity, And then you have the streaming platform. The legacy data connectivity connects to your data sources. It allows you to replicate the data. The streaming platform based on Apache Kafka allows you to move it in real time, and then also gives you the ability to have management and visibility into those pipelines and the movement of that data. So let me talk to you about a new approach from Software AG Connex and MeshIQ. It's a combination of these two solutions. Software AG, if you're not familiar, is a 50-year-old enterprise software company that provides an application development platform, a high-performance database, and data integration solutions. MeshIQ is a 30-year-old enterprise software company that provides middleware management and observability platforms for messaging and streaming solutions, and enterprise support for open source messaging and streaming solutions. The solutions provided by these vendors today are Connex from Software AG for data replication and connectivity, and MeshIQ Kafka for real-time movement and management. As you can see, it's the connectivity to the data sources, the transformation and the replication and the movement leveraging MeshIQ Kafka to whatever target you want that to be, whether it's cloud analytics, AI and machine learning, or data lakes. But the point is, with this combined solution, you reduce your costs, you simplify your environment, and you reduce the number of tools and solutions that you have to use. But enough of me. Let's show you this solution in action. So Demos, I'm going to turn this over to you. Demos?
Hi, thank you, Adam. Just want to do some housekeeping over here. You should be able to see my screen. Good morning, everyone. My name is Demos, as Adam said. I have two demos for you today. The first one shows you how to do live streaming from a mainframe database such as Adabas, VSAM, etc., to a modern database such as SQL Server or MongoDB. And the second one builds on the first. And as Josh spoke about AI and Adam spoke about AI, we leverage the power of AI based upon data that's coming from our system of record on a mainframe, streamed to a modern database such as PostgreSQL. And we have a small AI application just to demonstrate the features. First of all, in our first demo, we will have mainframe data that we will stream to MongoDB and SQL Server as the change happens. So we have live streaming occurring. The power of this approach is that we change once and we distribute every change as an event via Apache Kafka, and we synchronize to the target so that we don't have shadow copies. We don't have to do an extract from the mainframe to a batch file. So as the change occurs on your system of record, we see the change appear in MongoDB as well as SQL Server. Now, it could have been any one of hundreds of different databases, just showing the two here as an illustration. The first step is to set up a Connex data dictionary, which is really a roadmap of your data. From Connex's point of view, we see every database as if it's a SQL database. So we abstract the difficulty of the database away behind the scenes. And here I'm showing you what an Adabas database looks like in the Connex interface, in the data dictionary interface. And behind the scenes, Connex takes care of all the commands that Adabas needs, or SQL Server, VSAM, IMS, DB2. They're all the same. They all look the same from this point of view. The second thing we do is we set up a Kafka broker instance, and then we point to that. So from our point of view, we have a Kafka broker running on a specific server, and we point to that. It's very straightforward. So we have source and target in this Connex data dictionary, and in the great MeshIQ interface, we can manage our Kafka environment. And because it's such a great tool, we can easily see what's going on in the background. So the first thing is I want to show you that there are no messages in the Kafka employees topic. All we have is an empty queue. Now I'm going to go to a tool we use in Connex called Infonaut, and I'm looking at the database as if it's a SQL database, and I'm going to change a record. We call them records in the mainframe, and we have got Simone Adam that has a marital status of M. At the same time, before I change the record, I have previously streamed all the data from the mainframe application into my SQL database and Mongo database. So we have the same data in MongoDB as well as in SQL Server. And here is the Mongo database and the SQL Server database. So let's go back to our tool. We're going to change the marital status to an X here, just so that it's different. And when I navigate away from this, we'll see that this changes to an X, and it goes back to Adabas and updates it using an Adabas command. When we switch back to SQL Server and we rerun the select command over here, we'll see that this has changed to an X almost immediately. And in the Mongo database, the same thing. When we refresh the collection, we'll see that the status has changed to an X. So the value of this is that you don't have to write extracts. As soon as a change occurs in your system of record, we go to the change downstream, and the infrastructure has taken care of the change, and the change is ready almost immediately in your modern database. The second demo I'm going to do is builds on this, and we have an application where we have a VSAM banking application that's on a mainframe. We have customers, we have transactions, balances, historical records. As soon as anything changes on any one of those records on the mainframe, the extract happens with connects via Kafka, and is managed by the MeshIQ platform, and we stream those changes into PostgreSQL. So the summary is we have VSAM data on the mainframe, and it lands up in Postgres, where we have an AI application that runs on top of that. So we have customers, and we have streaming data that's coming in. As soon as a transaction happens or an event occurs, it streams down into this application. So we can have a look. We have our Kafka broker running here on this port. We're getting 16.63 transactions per minute, and the broker is live. So just to show you that this is a live application running in the background. And then we just to show you a little bit about the data, we have a 360 view of the data, looking at the complete customer with some AI. So we have an AI tool that analyzes the profile of the person and gives us a summary. Matthew has been a corporate client from 2021, credit score of 692, etc., gives you an overview of the customer. So let's go look at a different customer that might not be such a good customer. Now, this guy has got 5 active alerts, and we can see what's going on. So we suspect that some nefarious activity has been occurring with all these alerts. This is a good customer, but all of a sudden, all these alerts are occurring. AI gives us the ability to look at that. So now I'm going to show you our AI chat client. And what we do here is we're leveraging the data that's in Postgres. But again, to remind everyone, it's coming from a VSAM mainframe database application. And as soon as a change occurs on the mainframe, those changes are streamed into my Postgres application. So the AI is looking at real-time data within a couple of seconds of data as soon as it occurs. So the first question I'm going to ask is, just in the interest of time, I've pre-prompted it. Which customers need immediate outreach versus monitoring only? This advantage of this is that you can have a financial analyst or a banking expert use the power of AI to give them some background. What's actually happened in the background is I do a system prompt. You're a senior banking risk relationship analyst, and I tell it what I'm looking for. And then I pass all the data down to the AI engine, and it does the analysis. So the data is coming from my Postgres live data, as I said before. And yeah, we have an executive summary. It tells us Ryan Garcia and Lauren Rodriguez are customers we need to look at pretty quickly. What the fraud posture is, relationship posture. Now remember, this is a demo application, but just to show you the power of what we can do, some key evidence and what it recommends us we do. So let's look at one more example. Summarize. Let's look at suspicious recent transaction from customer 31, and it does the same thing. It goes ahead and passes all the data from customer 31 to the fraud engine, and it tells you what's going on and gives you the references of why we say what we say. So there's a good check and balance as to the information I'm presenting and where it's coming from. So in this way, we were able to take data that's that lives on a mainframe in a legacy database and expose it via Kinect's Kafka, Mesh IQ into a modern database and enable AI, the power of AI, to manage our data. Thank you. Back to you, Adam.
Great, and thank you very much for that demo, Demos. We really appreciate it.
All right, thanks so much. All right, the first question came in from Alan. Many organizations are investing in AI, but how do you determine whether your existing enterprise and mainframe data is actually ready to support AI initiatives like RAG, agentic AI, and real-time analytics? Who'd like to take that one?
This is Josh. I can take that. That's a very good question and a very common question. It's always about a few things. Usually the data is, for the most part, it's ready because it's live data that core systems are using. What it really comes into is, does anyone truly understand with these systems, because they've been built over time, understand the data that's in it so they can leverage it appropriately with regards to whether it's the analytics, whether it's agentic, or whether it's RAG, right? It's really about, hey, how do we get the most out of this data and leverage the UI against it, as opposed to just thinking of it as, I just need to ask this standard question because it goes well beyond that. That takes time to learn, but usually the data is ready to go. The only other part that starts to come into this is around data governance and data management. And this just begins to expand those programs that we work with customers on.
Great. Thank you so much, Josh. Okay, the next question came in from Sonia. The presentation emphasizes the risks of relying on batch, extracts, and stale data. Can you share examples where real-time access to mainframe data materially improves AI outcomes or business decisions?
Absolutely. So we have a customer where they run a nightly accounting set of batch jobs, and they run for about 8 hours. It has to be run at the end of the day. And if these things don't get completed, bills and other things don't go out. In other words, it's revenue generating. It's very, very important. And then they want reporting on those things. If they can just look at that data before those batch jobs run, or just get access to that data, it can immediately be seen. Now, that's just one example. We have other customers where typically batch jobs will be used to batch up data and move it somewhere, like into, let's say, maybe a data warehouse, which is fine. But then again, because you're waiting for that batch job to batch up that data and get to the data warehouse, the data in the data warehouse that, let's say, the AI is going to access is only as relevant based on when the last extract was.
Great. Thank you so much again, Josh. We only have time for really 2 more questions, and then we're probably going to have to wrap this up. Next question comes in from Nabil. A common concern is that modernization means replacing legacy applications. How does the Connex and MeshIQ approach enable organizations to leverage AI and streaming architectures while keeping core systems such as Adibas, IMS, VSAM, and Natural in place?
So I can start with that. One is modernization, especially for the mainframe, as we're working with customers, is how does the customer define that? And there's a lot of customers who are going to modernize and stay on the mainframe. Really what this is about is you keep everything in place. You don't have to change anything. You're just changing how you can now get access to the data that's on the mainframe. For now, let's say things that aren't on the mainframe that are going to access things via APIs or other things. And that's really what this is about. Keep your data, keep it in one place. Don't move it around unless you absolutely have to, but now make it easy so that more modern systems, applications, let's say services, AI, things like that, can now get to this data in real time, which is that more accurate data as opposed to the batch jobs.
Great. Thank you again. And the last question from Vinay, and then I'll hand it back to you, Adam. If AI applications are consuming data directly from business critical systems, what governance, observability, and security controls should organizations implement to ensure trustworthy and compliant AI outcomes?
Very good question. You want to take that, Demos?
I'll just start and then you can add on if you wouldn't mind. So it's a layered approach. So we always leverage the source system of record, the great security that you have in your legacy applications, be it top secret, RACF, or whatever you have on your legacy side. So that doesn't change. Within the Kinect's world, we have additional security in the metadata layer that you can protect the data in terms of users, groups, what they can do with the data. You can define down to the element level of what can happen with a particular data element. For example, you don't want certain groups to see salary information or pay information. So you can protect those. You can protect entire data structures such as payroll. And so it depends on the need of the application, but also the need to know. So you can define who can see what, and you can protect what happens with the data. Back to you, Josh.
Yeah, it's a great question. I'm just keeping an eye on time, and I want to hand it back over to Adam, but would love to continue this conversation as a follow-up with anybody that would like to dig into this further.
Great. Thanks, Josh. And thank you, Demos. We appreciate your time. Thank you, everyone, for joining. Please keep an eye out for some of our future sessions. And as mentioned, we'll send out a recording of this webinar over the next few days. And we wish you all a great day. Thank you, everyone, and have a great day.